Okay. Yeah. Good evening, Dr. Narahari. First of
Yeah.
all, we would like to thank you for taking the time to meet with us today. We are a
Mm,
group of four students. I'm Zara. We
mm,
have Nandhana,
mm,
Aarushi, and Disha with us. We are working on
mm,
a statistics project together, and part of which
mm,
is to interview a statistician. So, when we read
mm,
about your long career in teaching and research, especially
mm,
in the areas of uh, reliability in industrial engineering and quantitative techniques,
mm,
we thought it would
mm,
be a wonderful opportunity to learn from you directly. Today, we'd
mm,
not only like to hear about statistics as a subject, but also
mm,
about your journey, your projects, and your
mm,
advice for students like us. Once again,
mm,
we are really grateful for this amazing opportunity.
mm. Okay.
So,
You're
sir,
able to see me?
could you?
Yes,
You're
Yeah,
able
sir,
to
we
see me
can.
now?
yes.
Okay.
Yeah.
Tell me. Please go
Sir,
ahead.
so could you please share a bit about your current role and how you first developed an interest in statistics?
See, my current role is I'm a professor in the department. I have, after retirement, I'm continued as a professor in the Industrial Engineering and Management department. My current role involves teaching, consultancy, research, and also some bit of consultancy work, and all these areas are my current work. So I was introduced to statistics in my college days during the engineering degree, where we studied industrial engineering as a course, okay, in the industrial engineering course. Then subsequently, we studied a lot of subjects related to statistics, like quality assurance. Okay, quality assurance depends heavily on your knowledge of discrete probability distribution and continuous probability distribution. If you need to control the manufacturing quality, you need to use control charts. Control charts, the basic principle of control chart involves probability distribution for setting the control limits. So therefore, that was my initial introduction to the subject of statistics. Later, when I did my MTech in reliability engineering, I was deeply immersed in the area of probabilistic modeling, or stochastic modeling, as it was called. So, probabilistic modeling or stochastic model covers your ability to model phenomena by considering uncertainty. So, we cannot assume the world is a deterministic world. The world is probabilistic. So, therefore, if you have to model any phenomena, for example, if you want to do inventory planning, okay, in a manufacturing plant, you need to have probabilistic inventory models. That is what is going to give you results in the long term. Okay. So therefore, when I did my reliability engineering, I was exposed to probability distributions, stochastic modeling, and then application of this probabilistic model to quality and reliability engineering problems. So that is how in my MTech I solidified my statistical knowledge. After that, I got an opportunity to teach statistics a number of times in the Department of Industrial and Management. And so that built my expertise in the area of statistics, not only statistics, but the application of statistics to real world problems in the area of quality, reliability engineering, operation management, supply chain management, everywhere. Lot of scope for application of probability models to help and assist decision making in organization. This is the brief about it. Okay, please go ahead. Is
That's
there
really
anything else?
inspiring to hear. Yeah, yes, sir. That's really inspiring to hear about your journey, sir. Building on that, how would you describe the role of statistics within industrial engineering and management?
Okay. See, statistics and operation research, I suppose you are studying these two subjects now. Both of these are the pillars of industrial engineering, I will say. Because anything you want to do, study any phenomena, okay, with respect to manufacturing simulation, or with respect to business simulation, or with respect to engineering simulation, everywhere we use these two subjects, statistics and operation research. Statistics describes the phenomena and helps you in concluding about hypotheses that you formulate in your research area. And operation research helps you in deriving linear programming model and such other models which are helpful in decision making in organization. So both these statistics and operation research as pillar of the area of industrial engineering. Industrial engineers need to be extremely strong in these two areas for furthering their knowledge, whether at the master's level or PhD level. Then your basic knowledge and fundamental knowledge of statistics and operation research is going to go a long way in building your academic career. Not only that, if you're joining any industry, you'll find that there are a lot of application of statistics and operation research in real life problem solving. So that is how we have to be extremely strong in these two areas. And students, when they learn statistics, they need to learn the principles, the processes involved, and the steps involved in decision making using statistical models, and similarly in operation research model. So these are my two areas of strength, I can say, in my expertise that I have built up over the years. And I have done a lot of work using statistics and operation research along with my students. I've guided a lot of students to apply statistical knowledge and operation research in projects that they carry out in the industry. And many of these projects are industry-facing projects or real-life projects, which have given wonderful results to the industry, which sought these solutions by the use of our students and their knowledge. So this is how we have applied. Anything
That's
more
very
you want to?
interesting, sir. So, since you mentioned applications, so like in your research and teaching, which statistical tools or software do you find most effective and why?
Yeah, see, we are having a software called SysStat in our department, okay, which is a very comprehensive statistical modeling software. It has a lot of features and lot of routines that are built, algorithmic routines that are built into it. You can do any level of analysis using SysStat. That is one of the software we have. And SysStat is a major statistical company. I am also exposed to SPSS, statistical packages for social science research. And then there is a Minitab, which is extensively used in manufacturing industries for solving their quality and reliability related problems. So all of these, and you have also Excel, which has a statistical built-in routine, which you can use. And you also have solvers for solving operation research problems. And today, open source tools like R and Python, they are aggressively used in a lot of statistical libraries are built in, and you can exploit the Python libraries to build your analytical models based on data sets that you have. And today, as you know, we have moved from small data set to large data set. Okay. So therefore, the next avatar of statistics, which is analytics, consists of predictive analytics, descriptive analytics, and prescriptive analytics, and exploratory analytics. All these are extensively used in the today's market because data science has emerged as a field which is a offshoot of statistics. Statistics is some field which came in the 1700s and much before that. But with the advancement of computing and statistical software being available, the data science has emerged as a leading field with a large amount of data that is available, which is coming at a high speed, velocity, volume, and variety. Veracity. Both, all of these three V's are important. Okay. So therefore, a lot of application is there for statistics in its new form called data science. And also, you must have heard of the machine learning algorithms. Most of the machine learning algorithms have built-in statistical routines. Okay. Anything else?
Speaking of how to use these tools, how do you integrate statistical thinking into your courses and student projects?
Okay. See, let me give you a very simple example. Let us say you have a measurement. Let us say you are measuring your mobile phone. What are the dimensions of your mobile phone? Can anybody tell? What are the dimensions? When you want to say what is the dimension of your mobile phone? Okay, what is its length? What is its width? Okay, what is its depth? all these. When you use an instrument to measure it, are you getting results which you have 100% confidence, or there is some degree of uncertainty involved?
There is uncertainty involved.
Correct? Any measurement has uncertainty. So if you want to find out what is the level of uncertainty in the instrument that you're using, you need to use statistical models for that. Okay, you need to quantify the uncertainty. So therefore, you don't, supposing L is the length of the mobile phone, we take L plus minus delta X. Delta X is the level of uncertainty. So every measurement involves uncertainty, and we need to quantify the level of uncertainty. We need to use some kind of probabilistic model. So what we do is we take multiple measurements of the length, we plot a histogram, and based on histogram, we are able to guess what kind of probability distribution can be used for modeling the uncertainty in measurement. Okay, irrespective of whatever the technology you are using, there is always some element of uncertainty. The uncertainty can reduce as a consequence of superior technology, but cannot be zero. So therefore, modeling the uncertainty involves statistical modeling and statistical thinking. See, statistical thinking, you use the right word. The difference between statistical thinking and normal thinking is people believe in any measurement. If people believe there is no error, that is a deterministic thinking. People understand there could be error irrespective of whatever the sophistication of technology, then that is statistical thinking. So this is the difference between normal thinking and statistical thinking. I hope that clarifies.
Sir, so looking back at your long career, what has been the most rewarding project or experience which is involving statistics?
See, rewarding meaning, see, statistics is a tool. By itself, it cannot do wonders. It depends on the analyst, how you use statistical tool in your problem solving. So therefore, we have done a lot of work. For example, we did one project in long time when I joined my teaching career in Hindustan Aeronautic Limited. We did one reliability based project, okay, where we use aggressively the statistical modeling, okay, involving Weibull distribution, okay, and such other probability distribution we used for modeling the life testing characteristic. Okay, so it was an engine failure we modeled. So we took test data from the how much it has worked before it failed. That data we took, treated that as a random variable, then we did probability plots. From that we estimated the parameter. From that we could estimate what is the life of the engine, what is the predicted life of the engine. This is one of the high points in my career, where one set of students under me did reliability of aero engines long time back. That was in 1989 or 89 or 90. I don't remember the exact year. But reliability of aero engine study involved lot of modeling using probabilistic model. And we use log normal, Weibull, many of the continuous distribution, and treating the random variable is the time to failure. So based on that, we try to model the reliability of aero engine based on test data.
Sir, on a related note,
I'm
what
putting it
are the
very
some
simply. I'm putting it very simply for you to understand, but the process involved is a little bit more complicated than it appears in my dialogue. Okay.
Okay, sir. So, on a related note, what are some common mistakes students or professionals make when applying statistics?
Okay. See, you must know that statistics is like a lamp post, okay, for a drunken man. Are you getting the analogy? Okay. When you want to go through a very difficult terrain and you are drunk, you have no path for you. Okay. You need to have some lamp post or post to hold on to traverse through the jungle of the industrial problem. So statistics is a tool. People believe that statistics will give you all the solution. No, statistics is used as a tool, but you need to think through the problem, formulate a problem which is solvably stated is half solved, we say, problem formulation. So therefore, you need to formulate your research problem correctly for statistics to help you in solving the research problem. Okay, so statistics is a tool. People over judge the utility of statistics as being it will give you a complete solution. It will not give you a complete solution. It will help you and aid in your decision making. Decision making ultimately has to be made by the humans. Whether you are using data analytics or prescriptive analytics, all of these are decision support system. But the human being has to understand the context. In the context, he has to formulate the problem. Then he has to apply the statistical procedures step by step, lead to the inferences or conclusion. From that, find out the difference between statistical significance and practical significance and use it for problem solving. So students normally, when they use statistics, they expect wonders to happen. They expect magic to happen. Magic is in the numbers. Okay, the numbers that statistics throws up. Okay, you need to use it with caution. Okay, you need to find out how relevant is the result that is coming out. Okay, if you use a computer program, okay, and you have data which is of poor quality data gives you poor results, correct? So the responsibility of ensuring input data quality and use of the right kind of processing technique and reading the output correctly lies with the students. Okay, students have to be cautious that in choosing the input parameters for the model, the process sequence in which the model is to work, and then the looking at the output and reading the output and interpreting the output. This is the skill that is required for students, which you have to learn progressively to gain expertise in the use of statistics. Statistics can lie. I told you, I think I took one class to you. What are the myths of statistics? If you remember, we talked about several myths of statistics. So those are the things that you are to be cautioned again. So there will be what is called overfitting and underfitting of models, which you will have to be careful about. Okay. So it is all, there is a lot of judgment beyond statistics, which we need to cultivate by getting exposed to the real engineering problems in the industrial world. So therefore, you need to use statistics as a guiding post or a lamp post for a drunken man. That is the analogy I want to draw. There are very good books which talks about the statistics in a literature sense. Okay, one book I will always recommend is Lies, Damn Lies, and Statistics by Benjamin Disraeli. Please note down the author, Benjamin Disraeli. And then one more book called Standard Deviation by Gary Smith. Okay, this gives you like a fiction or a novel. It talks about what are the plus and minus of statistics, worth reading for all students to understand where statistics should be positioned in your mind to fix the usefulness of statistics in problem solving. Yeah. Anything
So
more?
linking to this industry, how do you connect statistical model with practical problems faced in the industry?
Okay. Here I would bring reference to one book we used to study when we were MTech students. Okay, this title of the book is called Industrial Statistics by Duncan and Smith. Okay, so this is the book. One more book called Engineering Statistics by Bowker and Lieberman. These two books are important. So in industry, measurement is inevitable. Whenever you want to talk about the quality of any process or product, you need to take measurements. And the science of measurement involves repeatability and reproducibility. Okay, we call it as gauge, repeatability, and whenever you do measurement, you either use an instrument or gauge. So there is what is called gauge R&R studies, which talks about the efficacy of the instrument or gauge itself, and to what extent we should believe the instrument errors and how to model that. So we use that in industrial problem solving. And the area of quality draws upon the statistical knowledge for industrial application. there is a subject called statistical quality control, or the industry calls this as statistical process control, which relies heavily on the statistical underpinnings to develop all the tools that are used by professionals in the area of quality. Whether it is control chart, we have 7 QC tools. Many of these 7 QC tools, whether it is a control chart, histogram, and scatter diagram, they use a statistical knowledge. So you can do any kind of modeling for industrial application.
Now, sir, to wrap up, finally, what advice would you give to students like us who want to build strong statistical knowledge and apply it in our careers as well?
Okay, first thing is you need to learn your statistics course through and through without leaving anything you should understand the concepts in the right way. Okay, so there are hundreds of books available in statistics. Okay, there are a lot of very useful contributors to statistics, you must know. So I will mention some of the contributors to statistics whose work stands testimony to the kind of body of knowledge that has been created already. You need to have access to those body of knowledge today. In the internet, you get a lot of information, but you must be able to build your foundation knowledge or fundamental knowledge correctly. After that, you get to higher level of knowledge. And therefore, statistics, which started with enumeration or survey-based statistics for census and other thing, then came into probability theory, then came into describing population relationship between variables, then statistical inference and design of experiment. Now you are in the computational methods of statistics, and now prediction, big data, causal inference, these are the contemporary area. So therefore, the field of statistics has evolved from being used in economic survey and other areas to becoming key enablers in industry problem solving by using probability distribution, regression models. Okay, and a lot of pioneers are there who have contributed to the field of statistics. Okay, so this is the way the statistics has evolved a field as a field. Okay, and a lot of contributors are there. It started with all the survey and sampling methods, and statistics was always known as survey and sampling methods. Then came probability models. Okay, due to the work of Roland Fisher, who gave maximum likelihood estimation, analysis of variance, experimental design. Then Newman and Pearson, they gave the concept of type 1, type 2 error, power of a test, confidence interval, and Bayesian theory. Thomas Bayes is another important contributor. Then came the statistics being renamed as data science. Whatever statistics basics now is called data science in the era of computer programming, resampling method, and the Bayesian method, which was the potential was not known, has been revived in the current era of data science as a classifier algorithm. So Markov chain, Monte Carlo simulation, and specialized fields like biostatistics, psychometrics, econometrics, spatial statistics. All these are fields that are emerged. Now we are in the 21st century. Here we have big learning, big data, which consists of volume, velocity, and variety of data. Then machine learning as applied statistics, high dimensional data, fields like genomics, neuroimaging have led to the development for dealing with situation where the number of variables far exceeds the number of observations. Then causal inference, etc. These are all the things. In fact, in experimental research, many of the Nobel Prize have used what is known as the randomized controlled trial as the experimental methods. Okay, and this is a famous RCT is a famous tool for social science research, also exploited in laboratory experiment in engineering science research also, and has been used in psychology a lot. Okay, statistics has no boundaries. It is all pervasive. Whichever field, without the support of statistics, you can't write a single research paper, because if you want to write a research paper, you need to collect data, you need to validate the result, and statistical methods are extremely useful for both industrial research, which is applied research, and also for basic research and fundamental research. Okay, so therefore, statistics has a very big role to play in industrial problem solving. Okay, both for giving insights through data and also inferences on what is actually happening in the phenomena. If, for example, I give you, let us say, I want to know what is happening in the within the atom in electronics. Okay, so it's a random phenomena. So therefore, here statistical modeling can be used, probability modeling can be used.
So this has been such an insightful session for us. We learned a lot from how statistics is applied in engineering and research to how statistics tools can make a difference to your advice on what skills we should focus on as students. What we really appreciate is how you connected statistics not just to technical topics but also to real life decision making. On behalf of our group, I'd like to sincerely thank you for your time, your stories, and your guidance today. This conversation has really inspired us and it will definitely add great value to our project as well as our future learning. Thank you once again, sir.
Thank you. So what I will do is there is one history and evolution of statistics document with me. You have sent me the link to the same mail. I will send the document. Please study how historical evolution of statistics as a subject has happened. Okay, so you do a cursory reading, you will understand the journey statistics has taken and how useful, and also you will understand the names of lot of pioneers and contributors whose work on which we are now today standing. Okay, for example, we talk about Mahatma Gandhi for all the freedom that we have in the country. So lot of these today's democracy is standing on Mahatma Gandhi's initial work. Same way we need to remember our people. And there is one statistician. How many of you heard of Indian Statistical Institute? How many of you heard Indian Statistical Institute? Okay, it is one of the apex institute which concentrate on research in the area of statistics. All the research in statistics, including the research required for our national planning, is due to a person called Mahalanobis. You Google, look at the Mahalanobis work. Okay, and our seminar hall where you sit and study, all your classes are held there, is called Mahalanobis Hall. Okay, so therefore you can look at the work of Mahalanobis, okay, and other contributors. I will share with you a document. It talks about the history and evolution of statistics. Okay, so if you give a cursory reading, you'll be feel inspired. Also note the names, and you can go into depth of anybody's work, the body of work that they have created. Okay, many of the books in statistics do mention about Ronald Fisher. Okay, then Gauss and many Thomas Bayes. All of these are big names in statistics. So you need to know who are the scientists who contributed richly to statistics. Okay, so both applied and theoretical statistics have a great value.
Okay, sir. Thank you so much.
So, okay. So what is your learning today? Nandhana, what is your learning today? Nandhana Suresh.
So I learned how statistics can be applied in real world problems and get to know about some important statisticians. I will definitely refer those books.
Okay. Zahra, what is your learning? Zahra.
Yeah, I learned that statistical thinking is really important in life rather than the normal thinking. And I'll also refer those books and refer to the work of the peer pioneers of statistics.
Okay. Aarushi.
Sir, I learned that statistics is basically, it has a lot to do with data. And by hearing your experiences and all the advices and the books you've referred, I also understand that it is applied across many fields to to make decisions and etc., I will definitely read and study all the books you've referred, sir.
Yeah, see, one name I forgot to mention. There is one person called Douglas Montgomery. Okay, I don't know whether the same book you are reading in statistics. If you are not reading, it's there in the library. Okay, he has written multiple books on statistics. Not only statistics, even statistics as applied to industry. Statistical quality control book by Montgomery is also there. The book by Design of Experiment by Montgomery. All of these gives you industrial perspective of statistics. He is a consultant and a practitioner who has exploited statistics throughout his academic work, and you will find a lot of papers of Douglas Montgomery online. He's a very important person, and Walter Deming is another person. So he's a Japanese. Deming is a Japanese. Montgomery is a American. Okay. So there are a lot of people. Okay. So I've mentioned only few names. Disha, we'll end with you.
Yes, sir. So it's really interesting to hear that how like statistics is also applied in very like technical fields, like how it's applied in physics and all like technical problems involved. So like it's applied pretty much everywhere. So it's very interesting to know that.
Okay, thank you. Okay. It's okay, we'll end. Can we
Yes, sir.
conclude?
Yes,
Yes,
sir. Thank
sir.
you, sir. Thank you so
Thank
much,
you.
sir.
Thank you, sir.
Thank you.
Thank you. Thank you, sir.
Thank you. Have a good day.
Thank you, sir.